to today's Knowledge webinar, Assessment of the Environmental Impacts of the Landscape in Rhino. This webinar overviews the landscape design process in Rhino. It addresses a workflow solution to assess the environmental impacts of the landscape project model with Rhino and Land Design. And after project is designed, we will see how the cooling effect, CO2, and the solar radiation absorbed by plants will be calculated through this workflow. So this is a really relevant topic. Today's webinar presenter are Elham Ghabouli, who is the landscape architect and the product manager of Lands Design at Asuni, and she holds a PhD in urban architectural management, and her focus is on BIM workflows in the field of landscape architecture. Furthermore, Francesc Salla is an architect and the product manager of VisulaARQ and Lands Design at Asuni. Francesc is a specialist in parametric design solution with Grasshopper. And now let me tell you a little bit about Knowledge and where you can find Lands Design and Rhino and VisulaARQ if you are interested. Knowledge is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, and faster service. Check us out at knowledge.com. Now, without further ado, I will share Elham's screen so she can take it away from me. Here you go.
Sure. Hello, everyone. Good morning or good afternoon, wherever you are. Let's start with our presentation today, and thanks for joining us today. Well, this is the topic is the assessment of the environmental impacts of a landscape in Rhino. Let's see what's Rhino first of all, and what's Lands Design. Lands Design is professional BIM landscape software. It works as a plugin in two versions, for Rhino and for AutoCAD. And it helps us to have drawing, a 3D model. It automatically generates the quantity takeoff list of plants and other materials. And there are several tools for animation and visualization of the project. Well, there are two versions of Lands Design. Both versions are similar, but what we are focusing today and the workflow that we are watching today is on Rhino version. The program is used in the field of landscape architecture, in green infrastructure, in urban planning projects, and also in environmental projects. And this is the topic that we are working and watching today. Let's just take a look at its main features. Lands Design includes an extensive plant database with more than 8,000 plant species. The plant database includes several filters that let us to select the adequate plant based on the climate, soil type, and other parameters. The plant database also includes botanical information of plants and the different representations of the same plant species. So these representations are going to be used in the model and in drawings later. There are different display modes, as I said, and so this is the conceptual. You can shift between conceptual to detailed just by one click, or to realistic as well. In realistic representation, we have also the seasonal simulation of the project. So you can shift from spring to summer or to winter to see that how will the project look like in different seasons. You can easily shift between 2D and 3D. And as you see in 2D, we have different blocks representing the 2D of the project or creating plans. And in 3D, we have 3D blocks that are representing the model. For inserting vegetation, there are several ways. Of course, inserting them individually. In addition, you can also insert them by paint mode. Just by moving the mouse on the plot, you can insert plants in this way. You can convert points to plants species. So if you have a drawing with points or with blocks like what you see right now, you can convert them to a 3D plant model in Lands Design. You can insert plants in a row as well. The row can be combined of different plants, or you can insert a group of plants and indicate the distance, the diversity, and so on. You can insert shrubs, indicating the number, the units per square meter or per linear meter, or of course in imperial system as well, or insert the ground covers, as you see. There are powerful tools for creating terrain, which is the topography, the main topography of the project. Once the terrain is created, you can easily modify it with control points. You can create and do different kind of earth moving operation, cut and fills, and so on. And Lands Design will record and will calculate the volume of earth moving operation all the time. So you will know that by each operation, how much is the volume of digging or extracting the project. You can import the terrain from the web just by looking the location of the project on the map. So this is a rapid site production for those that have no information, topography information of the project. Lands Design uses 2 different global elevation databases for producing the terrain in this way. So also you can create the 3D mesh of the selected area, including the satellite image. As you see here, we have a mesh with satellite image and a terrain, which is a 3D object. You can obtain the topographic contours of this imported terrain as well. In addition, another feature that we have also for the terrain is that you can import the buildings, surrounding buildings or buildings that are existing inside the project. In this example, you see the Central Park of New York. And as you see, by some clicks, you obtain the blocks, the building blocks that are existing in the project. We have dynamic documentation tools that let us to produce the list of plants, zones, furniture, earth moving, irrigation, and so on. You can add the image of plants or add labels and tags to the project as well, and finally produce different types of documentation, plans, sections, and so on. So the whole project can be done in Lands Design. So as you see here, the concept plan and different types of plans are made with the program. But we have hardscape tools that help us to have parametric hardscape, like parametric walls. You indicate the thickness and the height of the wall, parametric paths, parametric fences, and a block library of furniture. We have irrigation tools that let us to design the irrigation system of the project. And Lands Design will calculate automatically the volume, the quantity of pipes and sprinklers that are used. For visualization, we have several tools for work mode, for virtual simulation, sun and shadow tools. We have several render possibilities. Lands Design is compatible with the best render engines in the market. So you can obtain different animations and different images, photorealistic images. The animation that you see here, for example, is made with Enscape and the Lands Design. These are the examples of the results that you can obtain from Lands Design in Rhino version. The Enscape, Twinmotion, V-Ray, and Lumion are fully compatible with the program. And let's see its specific features of Rhino version. Rhino is compatible with more than 55 formats, including DWG files, SKP files. So if you have a drawing from AutoCAD, for example, you can open it in Rhino and continue working with that. Or if you have some blocks from SketchUp, you can import them into Rhino. Rhino is a useful and powerful tool for freeform modeling. The licenses can be on CloudZoo. We have IFC support in Rhino version of Lands Design, so you can export your project into IFC format. We have parametric design with Grasshopper, which is a solution for many issues and challenges that we face during the design. And we have another solution which is called Lands Design inside Revit. So once you have modeled your project in Lands Design, now with some clicks, you can open the project into Revit, and Revit will recognize it as its categories and families. Another feature is that parametric design is available in Rhino version of Lands Design. As you know, you may know, parametric design is a design method where we apply algorithms to create a geometry, or we apply algorithms to calculate and analyze an existing model. This is the interface of Grasshopper. Grasshopper is the parametric design tool of Rhino, which is quite famous and popular. I guess you already know that. So this is the interface, as you see on right of Grasshopper, and in this way we link different objects, algorithms, and analysis together to finally get the final result of our objective. So in summary, the design process with Lands Design starts from maybe by creating terrain, which is the basement of the whole project. You can import the terrain, or if you have elevation contours, topographic contours, you can elevate them. Once you have them elevated, you can create a terrain in Lands Design easily. You can do any kind of earth moving operation. You can zonify them, the project in different zones. Lands Design will calculate the area of each zone. You can assign different material and different textures to each zone, and so on. And continue, you insert plants, maybe individually or in a group or in a row, as you see here. Plants may have natural variation if you wish. So in this way, you will have a more realistic, let's say, feature of the project. Then you continue the project with inverting blocks or with hardscape tools. If you have some hardscapes, like you are going to have some paths, some walls, some stairs, and so on. So you continue creating them, placing them in the proper location. You can shift between 3D and 2D at any moment. So if you are going to modify, for example, the location of some objects, you can do that in 2D if you are used to in working in 2D. And then everything will update in the 3D model as well. Finally, you get the list of plants and materials just by one click. So by one click, you get the list of plants, furniture, zones, irrigation, and so on. Finally, and at the end, you will render the project with a render engine. In this diagram, we see how is the workflow with Lands Design. Basically, you need to start in Rhino or in AutoCAD or in Civil 3D. Once you have the drawing, and these programs are the main platform of the program, so Lands Design will be installed on top of them. Once you have the drawing in them, you continue modeling in Lands Design and enjoy its beam features. So in continue, for visualization, you apply a render which is compatible like Enscape, V-Ray, or 3Motion. You can apply virtual reality, use the headsets, and walk through the project in a virtual way. Or you can print your project with a 3D printer. For documentation, we have can export documents to PDF or Excel or printed drawings directly. You may have collaboration with other programs like SketchUp, 3D Max, or Revit through IFC, or in case of Revit, through Rhino inside Revit technology. If you have geographic data, for example, point clouds, DEM files, digital elevation models, or GIS files, these are readable with by Lands Design, and so you can create a terrain based on point clouds directly in Lands Design. Or if you have GIS files, you can open them directly into Lands Design. And now the feature that we are working and presenting today is the environmental analysis of a landscape project. So let's see how is the environmental analysis of a landscape project with Lands Design. In general, we use parametric design in two sectors. One is we apply algorithms through parametric design tool to create a geometry, like those amazing buildings, amazing features that you see every day that are increasingly getting popular. And the second one is that we use parametric design tool to link the data to a beam geometry and then continue to analyze the, do different kind of analysis. In case of Lands Design and in Rhino, as I said before, we have Grasshopper as the parametric design tool. Lands Design has its own Grasshopper components. So we have like Grasshopper components for plants, for a row of plants, for the terrain, and different kinds of different parts of terrain feature. This is a simple example of what we may have with Grasshopper. We can insert first a bunch of plants, and as you see here, there is a definition that we have created to have some plant pots for these plants, and the plant pot is related, the size of plant pot is related with the diameter of the plants. By moving the plants, the plant pot also is moving, and so this is the algorithm that is linking the size of plant with the plant pot. Well, it's a very simple example, but there are unlimited possibilities that you can achieve with Grasshopper, and some of them are those that we are going to watch today. So for environmental analysis of a landscape model, we need the environmental data. We link those environmental data through Grasshopper to a lands design model, or to a BIM model, and in our case is Lands Design. And then, well, we have automated analysis and we achieve to the results. So based on the algorithms that we apply, and based on the data that we introduce, we can get different analysis and different results. For example, we may have CO2 calculation, we may have shadow analysis, we may have cooling effect, and as well as solar radiation. These are some examples that we will see today, but there are unlimited possibilities that we may develop later on. So a model that is created in Lands Design will continue by applying Grasshopper and Grasshopper plugins, because there are inside of Grasshopper, there are many plugins that are developed for environmental analysis and climate studies. So some of them, for example, are Ladybug tools and Vallacy. So well, this was the end of the presentation. We can continue to see how is the model in Lands Design and how is the calculation that we are going to do with Frances.
Okay, we're going to switch to Francesc. And that was great. Thank you, Elham.
Hello, hi everybody. Thanks for attending this session today. All right, I'm gonna explain how to run shadow simulation analysis with this conceptual scenario. Imagining this is a kind of a public square or a public space. All right. So first of all, I'm gonna insert a few plants here. So I'm gonna run the plant command in Lands Design. So by default, I have here already some species, but I can also browse in the plant database for new species, okay, according to any details that I can select here. So there is many different options to filter this plant database to select the desired species, all right? And for example, we can select, I don't know, Nacer platanoides, for example, okay? So we select this plant and we define the size of it in the model. When we have this natural variation check, that means that if we insert several units, each one of them will have slightly different in their head, so it will give us a more realistic feeling, and we just insert the number we desire. So right now we are seeing these plans in the conceptual mode. From the Lands Edit panel that we can see here already open, we can switch from this 3D conceptual shape to the other representations, such as the elevations, the detailed, or the realistic, which is those that provide a more realistic appearance, and those that are used when we want to show the render of the scene. Even though when we do this, these plans are replaced by an even more detailed definition, a 3D block definition that integrates all the textures and realism for the image that we want to show. Also, when it comes to do some shadow analysis, the first thing that we can do is to take advantage of the Rhino Sun panel, okay, that that we can open from here. And when we activate the sun and we are using the current renderer lighting scheme, we can do some kind of pre-visualization of how the shadows are casted. Here, what I need to do is also enable the ground plane. Okay, so we can see these shadows are projected on the floor. These shadows are displayed according to geolocation of this model and according to date and time. So I can just by moving these sliders do a kind of preview of how the shadows of these plants will vary along the day or along the year. All right, but of course, this is just for visualization purposes. Now I'm going to show how to do a more accurate calculation of the area, shadow area, at one specific time and day during a year. And I'm going to use Grasshopper for that. Just for the sake of a good performance, I'm going to use the conceptual shape. Okay, so even though this may not give a better accurate results, it could be enough to have a good idea of what will be this area that we want to calculate. All right. Okay, now I'm gonna open Grasshopper. I have already this Grasshopper definition, which defines here some values for the year, month, and also time that we want to run this analysis. And what I need to do is to define an area. So also I can specify which is the area to do this calculation, right? So I'm gonna do right click on this component, reference that curve. And well, now I may need to run this, recompute this definition. Now we can see the area of this plant shadows, and here the total amount of square meters in terms of the area that these shadows is casting. Okay, if I move this out of this perimeter, we can see that only the area inside this boundary is performed. Okay. All right, of course, if I change the dimension of these plants, okay, this area will increase. So basically what the definition does is using Lands Grasshopper components, I can reference all the plants that are existing in this file. With this component, I deconstruct them. I mean, I convert all the plants which are blocks in Rhino, kind of a smart blocks, right? We explode them in order to obtain the resulting geometry, in this case, VREPs. And with this mesh to VREP to mesh component, we can plug this into this mesh shadow, which generates the outlines of these plants onto the horizontal plane. So finally, I just need to merge the resulting curves. Okay, so they are calculated together when one plant is next to another. And that way, since we've got these boundary curves, we can measure the total area of these curves, right? I can finally put a hatch pattern to visualize better the results. And of course, these values that we've got here are always linked with the 3D geometry. That means that if we, for example, increase the number of plants because our design requires more shaded area, we can just well, check the results immediately when we open this definition. Okay, now I'm gonna show another example. In this case, how to calculate the CO2 absorption data. And I'm gonna use a new definition for that. Okay, and well, this definition collects the absorption data, the CO2 absorption data of a list of defined species that we can see here in this list. And basically, this data is provided by the Ministry for the Ecological Transition and the Demographic Challenge. It's a Spanish organization that has collected that data for all these species. Okay, just noted that some species collect different variations of plants of the same species. And well, basically this definition calculates the CO2 absorption of these plants based on a period of years that we can change here, right? We can specify that we want to analyze the CO2 absorption during 15 years, and we can measure that from the date to the future. Okay, so the days, years after the analysis, or we can do it before the date of the analysis. So basically, right now, we are measuring the CO2 absorption of this plant species from now to 15 years in advance. All right, and we can see here the results. So this is measured with tons of CO2 absorption, and we can see here the amount of units that well, this calculation is taking into account with the value. Actually, I'm gonna switch this to the top view, because this definition also shows this diagram where we can see all the graph of all the species with the evolution of this CO2 absorption along a certain period of years. Actually, the data that we have for these species, let me show you here. It's measured according to a period of 20 to 40 years, counted every 5 years. That means that we basically have real values from this point to that other point. The rest of the graph is calculated automatically doing an interpolation of all the values for the species. And the one in the red, the red line corresponds to the species that we have in the model. All right. Now, if we change the period of calculation, you will see that this point moves, specifying the endpoint for the calculation. Also, we can change the age of the plant species at the beginning of the analysis. So, assuming that, for example, if we are using here some Acer, we can tell that this Acer starts to being calculated when these species are 10 years old, right? So this calculation will be measured from that point. Now you can see here the period highlighted between these two points. And well, if we specify here, maybe we need to put this in enough age, so we can also select here the period of calculation before the current date. All right, this will switch to that other period, and we will be able to calculate how much CO2 has been absorbed during the past 11 years. Okay. Now, I'm gonna put this back to calculation after the date of the analysis, and we can see this in a more advanced example, let's say. So I've got already this project here. Basically, here you can see the a park that has some forest in it, also has some plants arranged in rows or also individually. And well, Lands already provides some tools to list all the species that are being used in this model. So basically here with a plant list, we can insert this list, and this will well, show the amount of units for each plant species that we have in this project. This is a to-do list that is linked with the 3D model. For example, if we select this row of citrus. All right, we can already see that we've got 30 units. And if we change, for example, the parameters of the row and set it to 8 units, all right, we will see how this number has changed, okay, since we have less units here in this row. But now let's see how this CO2 absorption performs in this project. So I'm gonna open a Grasshopper. I'm gonna open this file. Okay, I'm gonna ignore this. And I'm gonna show this from the top viewport, so we will be able to appreciate better the 2D diagram. Actually, it's now, we can see it now here, but I can just, with this point, move it to another position. I'm gonna show it here. So again, here in this case, the diagram shows more red lines since we've got more species to calculate. And if we check the results, okay, we can see here the different species with the total amount of units for each one and the total amount of CO2 absorption that each one performs, right? With the sum of all of them. And again, well, here we've got some tool to export these to as a text. And well, again, from this list of sliders, we can define the initial age, the date of the analysis. Okay, so we can take the ABS and say that we assume that these species are 7 years old, for example, when we start this analysis, or the Acer also are, for example, 7 or 8 years, whatever you want to specify. And of course, these values will update when you do these changes. At the same time, if we do any modification on this design, for example, we select the forest, and this is actually a forest of a combination of 2 different species, ABS alba and acers. We can, for example, change the units, the number of units, and say 80 instead. Okay, so there will be more items inside this forest, and of course, these values will update accordingly. All right. So this tool can be helpful to make some, to take some decisions according how the design, how the amount of a species or the specific species that we use on one spot or another can affect the CO2 absorption, and this tool can affect our decisions when we project some landscape project design. All right, so I'm gonna leave it here and let you continue, Elham.
Yeah, sure. Well,
Okay, we can see your screen. Perfect.
Can you see my screen?
Yeah.
Yes?
Yes, yes.
Okay, okay. So let's say this example that we have a few plants here in Lands Design. And as you see, the plants are some deciduous plants. So we are going to calculate the solar radiation that is going to be absorbed by these plants. From Rhino sun panel, we can indicate the location and the time and the date of the year. So in this way, we see that how is the shadow and the current situation of the project. And then, since we have got the Grasshopper components of Lands Design, we can introduce that in Grasshopper. For solar radiation of trees, we apply a tool in Ladybug Tools, which includes the calculation and all scripts of how to calculate the solar radiation. What we do here is just to link the geometry, the plans of lands design as the geometry of Grasshopper. We introduce that as a geometry, and then the script will calculate the solar radiation that is going to get absorbed by these trees and by each leaf of this tree based on the location and the orientation of these trees on the plot. But as you see here on the right side, we have the ladybug. So let's just have a preview. And as you see, if we see the legend, we will see that how is the radiation absorbed by each part or each leaves of the plants. And so even it depends on their direction, as I said, and the orientation of the plants. So in continue, we can also have this calculation when we have more geometries. Imagine that we have a park or we have a project that there are some buildings or some other geometries inside the model. So in this example, so we have like some other buildings next to the trees, and let's see how they may affect the radiation that will absorb by plant. We link these geometries as also some geometries in Grasshopper, and once we introduce them as geometries of Grasshopper, we see that the radiation that is getting absorbed by plants are a little bit different. Let's just make this definition and see that how it will be in Rhino environment. So we can close the Grasshopper, and now you see that how is the absorption by plants on this project. In this way, we can decide about the location of plants, if we have some plants that are are requiring more lights or less lights, and so on. In another example, I'm going to show you this one, which we are going to see how is the cooling effect of plants. Again, we have a bunch of plants, and what we are going to see is that how plants, how trees can have an effect on reducing the temperature in the cities and of course in our study projects. So imagine that we have some trees here, and what we are going to know is that how these trees are helping us in reducing the temperature. In this example and in this type of calculation, we need to apply the weather data of the location, the climate data. And since we are based in Barcelona, this example is from Barcelona. We are going to study the hottest week of the year in Barcelona, which is the 24th of July, for example, is one of those days, those hot days in Barcelona at 2 p.m. We make the geometry, we introduce this as geometry in Grasshopper, and what we do here is that let's see how these plants can reduce the temperature. Okay, so we introduce we see that how basically in that temperature and in that climate, how these plants will have effect. As you see now, we got the result. We can show that in Rhino, and when the hottest week of the year, the rest of the surface is 38 or 39 degrees Celsius. Under the shadow of these trees, we have 32 or 31 degrees. So there are 6 or 7 degrees of difference between those covered by shadow of these trees, those surfaces that are covered by shadow of these trees, and the rest of the project. Well, that's good to know that, but let's see how would be this during the winter. During the winter, we want another we wish to have less a hotter temperature maybe, and that's why let's see how these trees will have effect on the surface during the winter. As you see here, we indicate the location and we get change the date of the year. So now we see that we have long shadows during the winter, and these are deciduous trees, so we don't have leaves or foliage. Well, again, we do the calculation, we apply the scripts, we indicate these trees, introduce them as grasshopper geometry, and run the calculation. Okay, but as you see now on the surface, you see that the rest of the surface is around 30 degrees, and a few spots of the plot which are covered by the shadow of the plants are about 4 degrees or 5 degrees. So again, there are 6 or 7 degrees of centigrade of difference between those covered areas and the rest of the floor. Well, also we can compare these two results together. I mean, let's see how is the effect of these trees on the surface during the summer and how is during the winter. This helps us to select the adequate plants, adequate trees, maybe evergreen or deciduous, on the surfaces that we wish to have maybe less temperature during the summer. And if we want to have more temperature during the winter, also we need to have deciduous trees, maybe, and so on. Or otherwise, if you don't want to have like shadow during the summer, we don't apply those, maybe those plants with big crowns. Well, this is an example, but it shows us that how we can select plants based on these benefits in urban areas, especially when we are dealing with urban heat and heat islands in the city. How these plants, and again, in general, how vegetation can help us in reducing the temperature and so on. Hope you like this video and this workflow. I don't know if is there any question I can help, I can answer or no.
No questions so far, but wow, what an amazing tool, especially in these days of global warming. You can do all this if you have Rhino and Lands Design, boom, super useful. We're here for question. If you guys, this is the best time. You have the, the experts with us, and this is the best part.
Maybe it's worth it to mention that all these definitions, Grasshopper definitions that we have shown today, they are available for free on Food for Rhino. So you know that Food for Rhino is the platform where you can find all the plugins and resources related to Rhino and Grasshopper. So you can find these definitions there if you want to test this out with your projects, or you want to explore how these definitions are done. They are available. Okay.
That's great
also
news.
Also there are some tutorials that we have shared on our YouTube channel, just in case that you are interested and you are going to learn it more, how to do this calculation and how to repeat this calculation by yourself.
That's great. Thank you so much. And so, no, thank you so much, guys. Francesc, did you want to add anything?
No, that's it. I mean, I wanted to make sure that people know that they can get these resources for free. So that's it.
And that is fantastic. Thank you so much. I will take the screen back. I hate to do so, but it's necessary because I need to show everybody where they can get Lands Design and noveg.com. And of course, Noveg is very convenient beside the prices, because you can get your Lands Design, you can get your Rhino, VisulaARQs, and anything else you may need for your design. Let me see, we might have a question. It looks like there's a version available for free trial. What restrictions apply to that version?
Nothing. Actually, nothing.
Okay,
So
just the
the
time of
evaluation
the
version includes like all
everything.
features and everything.
Okay, wonderful. Check it
Mhm.
out. Yes, go and, don't walk, run. Okay, I want to thank you again for joining us today. That was illuminating.
Thank you too,
And
Barbara.
yeah,
Thank
looking
you.
forward already to the next webinar. Have a great rest of the day or night. And till next time. Bye bye, everybody.
Bye bye.
Bye bye.